ANSI requires that draw-out breakers must be open and remain trip-free during the racking process. The simplest, least expensive way to perform that function is to mechanically hold up the trip paddle. Should a breaker under this condition somehow receive a close signal, the breaker will attempt to, but not close or latch. In the case of newer vacuum breakers, the contacts may very briefly touch, sometimes known as kissing, and continue to trip back open. If you happen to be working downstream from this circuit breaker, no love will be found in those kissing contacts. Here we see America's all-time most popular medium voltage air magnetic breaker, the General Electric Vertical Lift MagnaBlast. The MagnaBlast never took this least costly approach to trip-free safety. To raise or lower a MagnaBlast breaker, this solid shaft extension, which is part of the positive interlocking assembly, had to seat into a corresponding mating assembly in the switchgear cubicle that then rotated a dozen or so degrees. This shaft was held mechanically immovable. It could not rotate unless the breaker was tripped open. With the breaker open, the interlock's rotation swung these two substantial half-inch thick steel legs mounted on a 1-inch thick steel rod, so they were now positioned directly in the path of the closing mechanism's moving parts. At the same time, the rotation of this assembly opened a closed coil cutoff switch. MagnaBlast breakers therefore had to be tripped open to be able to rack, the closed coil was automatically open-circuited, and the closing mechanism was physically blocked from operability. Let us now look at a 3AX operating mechanism on a fixed-mounted Citadel element. When raising this lever located on the base of the mechanism's enclosure, an internal linkage is raised that completely blocks the 3AX closing mechanism. The block the close lever can only be raised when the mechanism is in the tripped open condition. With the mechanism in the closed condition, this solid cam, welded to the main armature shaft, swings into an interfering position, completely inhibiting the upward motion of the block the close lever. With the Citadel charged and tripped, if we try to close the breaker mechanically, pushing on the close coil, or by electrically operating the close circuit, under all of these conditions with the block the close lever raised, the Citadel element cannot be closed. Lowering the lever permits normal operation. Taking this knowledge of the fixed-mounted Citadel element's block the close lever, let's see how it translates to the draw-out version of the Citadel breaker. To begin with, the Citadel takes a multi-level approach to interlocking. A closed draw-out Citadel drops a full metal curtain in front of the racking port. This initial curtain completely inhibits even the insertion of the racking tool. This is the first of the boundary gates. Unless the Citadel is tripped open, the racking tool cannot enter the racking port and will simply be banging on a closed door. By tripping the Citadel open, this first boundary gate rises. A second steel plate is now noticeable. This second steel plate comes down halfway so that it looks like a half moon when viewed straight on through the racking port. This second half moon plate is directly attached to the block the close lever. Under normal conditions, we would not be able to even see this half moon plate if the breaker were closed due to the boundary curtain being in front of the half moon. However, if we could somehow get past the boundary curtain, inserting the racking tool and trying to rotate it would be to no avail, as we remember that the half moon plate, being solidly tied to the block to close lever, cannot rise up if the Citadel is in the closed condition. With the Citadel tripped open, the boundary curtain is lifted. The racking tool can now be inserted into the racking port. Rotating the racking tool a turn or two will fully seat the tool so it is now sitting beneath the half moon's opening. Continued rotation of the racking tool will lift the half moon plate, engaging the Citadel's block the close mechanism, opening the motor charging and close circuit cutoff switch, and raising the positive interlocking floor pin. Learning from the Magnablast, for the entire racking process, indeed during the entire time the racking tool is inserted into the Citadel, a Citadel draw-out breaker is in the block the closed condition. Specify Citadel, no equal.